Hello everybody. This is a short introduction into two new coordinate systems, cylindrical and spherical coordinates. We already are very used to using Cartesian coordinates, and in the previous section we also learned about polar coordinates. Cylindrical coordinates extend polar coordinates into 3 dimensions. So over here, let's look at, let me get the pen, let's look at coordinate axes x, y, and z that we are used to. And instead of describing a point Q in terms of x, y, and z, we can describe it in terms of r, theta, and z. R and theta are the same quantities that we used in polar coordinates. So down here in the xy plane, right below the point Q would be the point x, y, and 0, since the z-coordinate is 0, but x and y are the same, then as they are in Q. And so r is the distance from the origin to this point with coordinates x, y, 0, and theta is the angle that the line from the origin to the point x, y, 0 makes, is the angle between the positive x-axis and this line connecting the origin to the point x, y, 0. So over here on the right, we are seeing conversion equations. If we want to go back and forth between Cartesian and cylindrical coordinates, we can use these conversion equations. X is r cosine theta, just as it was in polar coordinates. Y is r sine theta, and z is just z. If we want to go the other way, we also have the relationship that r squared is equal to x squared plus y squared. The tangent of theta is y over x, and again, z is equal to z. So that's cylindrical coordinates. Spherical coordinates use inputs or coordinates rho, theta, and phi. So if we have a point right here, Q, then rho is, let me gotta go away here, sorry. Rho is the distance from the origin to the point Q, that is rho. The angle theta is the angle with the xz plane to our point, and the angle phi is the angle that the line connecting the origin and Q makes with the positive z-axis. So that is phi. Again, we have conversion equations. X is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, and z is equal to rho cosine phi. And we also have the relationship that rho squared is equal to x squared plus y squared plus z squared, which you may remember is the equation of a sphere, so spherical coordinates.